All right, today we're going to cut through all the noise surrounding some of the biggest buzzwords in tech. We're going to build a super clear mental map so you can finally, truly understand the difference between all those AI terms you hear thrown around every single day.
So you've heard them everywhere, right? Artificial intelligence, machine learning, deep learning. And a lot of the time, they're used like they're the exact same thing. But are they? Let's dive in and get this sorted out, once and for all.
And look, this isn't some far-off, futuristic concept we're talking about. As this quote says, AI is already here. It's woven into our daily lives. It's the engine recommending movies to you, curating your news feed. It's already a fundamental part of our world.
Okay, so to really get a handle on the differences, let's start with the biggest idea first. I want you to think about it like a set of those Russian nesting dolls. We're starting with the largest doll on the very outside.
That biggest doll, that's artificial intelligence, or AI. This is the whole shebang. It's the entire field of computer science that's dedicated to one massive goal: making machines that can think or act intelligently. Mimicking human abilities like problem-solving and learning. It's the universe.
So if AI is the universe, how do we actually get a machine to be intelligent? Well, for that, we need to open up that first doll and see what's inside.
And inside, we find machine learning, or ML. Now, this is the crucial part. Machine learning is a subset of AI. It's one of the most important ways we achieve AI. Instead of a programmer writing millions of lines of rules, we just feed the computer a ton of data and let it figure out the patterns for itself. It's the engine that allows AI to learn from experience.
But what about all the really revolutionary stuff we're seeing right now? AI that can generate incredible art, understand complex conversations, or even help drive a car. That takes an even more powerful, more specialized kind of engine. So it's time to open up the next doll. And here we are, at the very core of it all, deep learning. Deep learning is a specialized type of machine learning. So if there's one thing you take away today, it's this: AI is the overall field. Machine learning is a key approach inside of it. And deep learning is a powerful, cutting-edge technique within machine learning.
So what actually makes deep learning so deep? What's the secret sauce? Well, the answer is all about how these systems are structured. Let's peel back one final layer and look at the mechanics.
You see, deep learning is built on something called artificial neural networks. And just like the name suggests, they're inspired by the human brain. They're made up of layers of interconnected digital neurons that pass signals to each other and work together to process information.
And here's the best part, the thing that demystifies the whole term. The deep part, it's not some metaphor for profound thinking or anything like that. It literally just means the neural network has a lot of these layers. We're not talking 2 or 3, but maybe hundreds or even thousands.
This is a perfect way to visualize it. Data comes in at the top, into the first layer. That layer does some processing and passes its results to the next one, which then looks for even more complex patterns. And this continues, layer by layer, with each one learning something more abstract than the last, until finally, the last layer gives us the result.
Now, of course, this isn't just magic. It's all driven by some really sophisticated math. You've got linear algebra, which gives us the tools to represent all that data in a way the network can work with, as vectors and matrices. And then you have calculus, which is what allows the network to actually learn by measuring its own errors and adjusting itself to get better and better over time.
Okay, so that's the theory. But how does all this tech actually translate into the tools that we use every single day? Let's take a look at the real-world applications.
Within deep learning, there are specialized designs for different kinds of jobs. 2 of the most important ones are convolutional neural networks, or CNNs, which are absolute wizards when it comes to visual data, like images. And then there are recurrent neural networks, or RNNs, which are brilliant at handling sequential data, like language and speech.
And believe me, you interact with these all the time. That CNN architecture, that's what's powering the facial recognition that unlocks your phone, helping doctors analyze medical images, and allowing self-driving cars to see the road. And meanwhile, RNNs are the magic behind language translation apps, the voice assistant on your phone, and all those chatbots you talk to online.
The crazy power of these models means that understanding deep learning is an absolutely massive deal for anyone in tech right now. It's created this huge demand for specialists, people like deep learning engineers who can actually build, train, and deploy these systems to solve real problems.
So we have AI that can analyze, predict, and even create whole new things. But the technology is already taking its next giant leap.
moving way beyond just being a tool that gives us information.
And this quote just perfectly captures this next evolution. The whole game is shifting from AI as an assistant to AI as a doer. This is the rise of what's being called agentic AI. We're moving away from systems where you have to give it step-by-step commands. Instead, you can just give it a complex goal, and it can independently figure out the plan, make decisions, and actually execute the tasks to get it done. It doesn't just answer, it acts.
And this leaves us with a huge, provocative question to think about. When AI makes that final jump from a tool we use to an agent that acts on our behalf, autonomously booking our travel, managing our projects, or running business analytics, what does that really mean for the future of work and for our world? We'll leave you to think on that. Thanks for watching.